Great. Thank you, Bruce. Do I sound okay?
Yes.
Excellent. Thank you, everybody, for listening. Love to talk about deep sea corals, so I appreciate the chance to get a little bit of deep knowledge going today. So I'll provide an introduction to deep sea corals and sponges and a little bit about our work at NOAA. And then our following speakers will talk about classroom lessons and activities that draw upon these ideas. Before I say anything else, I really want to thank Greenfire and especially Eva for working with us to develop the deep sea coral curriculum that she's going to share today. I just can't say enough good things about it. It's a really fabulous resource, and I'm so excited that we got the chance to work with them and to develop this product that hopefully everybody can use. So NOAA's Deep Sea Coral Research and Technology Program has only been around for 10 years, but it supports research around the country. And many of our priorities come from the resource management community, from fishery management councils, from sanctuaries, from regional resource managers, as well as researchers, NGOs, industry groups, tribes, and a number of different entities. We have really strong partnerships around NOAA and other government agencies, as well as academia, among others. So I can't start any other way than just to show you a little bit about these fabulous creatures that most people don't know about. First, I'd like to thank Ocean Exploration Research, which is a part of NOAA that we collaborate with quite a lot, and the Monterey Bay Aquarium Research Institute for most of the pictures that you'll see here tonight. Most of these animals on the screen right now are corals, but I'll tell you which ones are sponges if you're not sure in a little bit. So corals are colonial animals, as I think most people know. They're found in a huge range of ocean conditions. Everybody knows about shallow corals, but the thing about deep corals is they don't depend on warm water or sunlight. They don't have photosynthetic symbiotic friends living in their tissues, and so therefore they're not limited to these shallow sunlit waters, and they're distributed throughout much of the world's deep oceans. We've found them all over the planet, and I'll show you a picture of that later. Sponges, some of them look just like shallow water sponges that you've probably seen plenty of photos of, since they filter feed just like deep corals do. But others, and I'll show you, I think you can see my mouse. This is a sponge right here. It's the ping pong tree sponge. It's kind of crazy looking. And this is the harp sponge. These two center left photos. Those are called carnivorous sponges because they actually have barb-like hooks that capture prey. Most sponges don't do that, so these ones are a little weird. And one of the main themes about deep sea corals and sponges is that we're finding new things about them all the time, and a lot of them are pretty weird, and we love that. So our program and a number of partners studies deep water corals and sponges. And looking at these photos, you can see they really come in many shapes, sizes, colors. They also provide habitat for many types of organisms. And so I'll show you that a little bit more on the next slide. Just a few fun facts for you. I'm sure everybody knows the deep sea is one of the least explored environments on Earth. And really relatively little is known about it. But I wonder if you knew that over half of all known coral species are found in deep, dark waters. So we've described over 3,000 species of deep corals already. They come in soft corals and stony corals. You could see a little bit of that on the slide before. And it's important to note they grow very, very slowly. It varies depending on the type of coral, but often it's a whole order of magnitude more slowly than shallow corals. So I think this is a perfect time for our first poll question. Bruce, please. Did it come up on? Oh, there you go, poll open. Do I have to swap my screen?
Sorry. Sorry, Heather. No, you don't have to do anything. So
Okay.
everyone, if you will click on your screen for the answer which you determine to be best, we will automatically be collecting the answers to these. and we'll let you know. So we're just going to take about a minute to collect these responses about how big is the largest deep sea sponge. Is it as big as a school bus, a minivan, a VW bug, or a bicycle? So we're
And this
just
is the largest known discovered deep sea coral. There's a deep sea sponge. We don't know what's out there. There could be even bigger ones.
right. So please take a moment to do this. Just a quick note that for those of you who may be using an Apple tablet or looking at or watching this on perhaps a mobile phone, you may not have the ability to answer this poll. There are sometimes some quirks with the software, but everybody else should be able to. We've got about 82% of the folks having voted. Everybody just take another few moments to put your answers in, and then we're going to close up the poll. Okay, and let's see what people said. Can you see this, Heather?
No.
Okay, it looks like 29% said that it was as big as a school bus. 31% said it was as big as a minivan. 31% said it was as big as a VW bug, but only 10% said it was as big as a bicycle.
Okay,
So,
well, definitely on the right track. It is minivan. That is the answer. You are looking at the biggest known sponge to date. It was about the same size as the remote operated vehicle that found it.
wow.
And I'll share with you a great video a little later on that captures the essence of the discovery when the researchers found this thing. And believe it or not, that was a Jeopardy question, and the contestant got it right. So that's why I love to ask it.
Cool.
Yeah. So then back in the coral world, this is the largest known soft coral, and it's over 18 feet tall, which just blows my mind. On the other side of the coral world, reef developing corals made of many colonies can be miles long and over 100 feet high. So these things just get enormous sizes. The oldest marine creature in the world is believed to be 4,265 years old. It's a black coral, like this image right here in the bottom center. It's called black coral because of its skeleton. You can see right there the black part. When all the tissue is gone, it's completely black, kind of ebony looking. That was discovered in the Pacific Islands. And this cross section right here shows how we have been aging coral. This one's about 44 years old. Last piece of trivia for you, the deepest known coral is over 20,000 feet deep, which is deeper than the highest mountain in North America. Mount Denali is tall. So I hope I've convinced you that these are seriously incredible animals. Next, we have a little more convincing if you weren't there yet. Deep sea coral can create complex 3D habitats, and you can see that in a few of these photos. On the bottom, this is more of the reef developing corals that I was talking about last time. And up here in the top left corner is these soft corals that provide habitat, but on a much smaller scale. So these productive habitats also act as spawning grounds and protection for commercially caught species like grouper, snapper, sea bass, rockfish, shrimp, lobsters, crabs, and many others. They hold records on ocean climate and productivity that can really help reconstruct past oceanographic conditions. Some corals, and especially some sponges, show anti-tumor activity, and this little green sponge right here in the center has been in the news a bit in the last few years for its anti-cancer, theoretical anti-cancer activity. So these animals really support ecosystems on multiple scales. The expansive reef building habitat, like down here in the corner, to really small colonies that still provide habitat, like these guys. And then thinking on even smaller scales, individual sponges can contain huge numbers of symbionts in their microbiome. And this really might be why they're valuable for medicine. So moving on to how we actually study these things, partnerships are incredibly important in this line of work, given the vastness of the deep sea and the expense of this kind of research. Multiple offices in NOAA, as well as other agencies and academics, send ships, as you can see here. Remotely operated vehicles, like this one and this one right here, as well as autonomous underwater vehicles, which I don't think I'm showing a picture of, towed cameras, and plenty of other devices that we have to try to study the sea. But we don't search blindly. Resource managers tell us where and what information is needed to make informed decisions in their regions. They're trying to balance deep sea coral and sponge protection with economic activities. So what we start with really is mapping, and you can see in this large picture a NOAA ship mapping the seafloor. It's conducted it's conducted for a lot of reasons, but we like to do mapping to find good places to look for coral habitat, and that's what's going on in this image right here at the top. You can see all these different colors correspond to depth. The redder the color, the shallower the depth, and so this purpley blue area is getting quite deep. There's lots of interesting features, like right here there might be a ridge, for example. You might find a habitat that looks sort of like this. We have some idea of what this kind of habitat mapping might look like in real life, but really you never know till you get there. This particular image was from the South Atlantic, and right now we're really focused on the South Atlantic and West Coast doing research for management in those areas. A recent example of a highly successful cruise that searched for deep sea corals and sponges based on mapping work that NOAA and others had done is last summer's documentation of a reef that's estimated to be 85 miles long, continuous coral reef. And it's likely hundreds of years old. You may have seen a number of articles about that this summer, and if you haven't, please take a look. It's really fascinating. South Atlantic resource managers are currently using this information to inform decisions on deep sea habitat protection. So it's been an exciting time to be down there with an ROV looking for corals.